Alright guys, so here is the average atomic mass practice answer key. Now with this average atomic mass, do me a favor. Don't just be watching this video to write down the answers on your paper. I'm not taking this up. Then why did you give it to us, Mr. Hall? I gave it to you for practice because if you have questions, it's a way for you to check. If you got questions, come ask me so I can explain and help you with these things. All of these problems, I'm going to do them so that you're not at home struggling and left up a creek without a paddle. I want you to have access and as much help as you possibly can have. So, let's start working these. I'm going to say they're all on the same difficulty. I want you to remember things that you need to do. The steps, keep the steps the same. It doesn't matter if there's 7 isotopes, 2 isotopes, 4 isotopes, 5 isotopes. Does not matter. Same steps, and that's what we're going to do the whole time. So let's get started here on number 1. So we have neodymium. The element neodymium, it has 1, 2, 3, 4, 5, 6, 7 isotopes. Don't get caught up on the number. Just follow the steps. It's the same steps. This average atomic mass, I'll add a bunch of isotopes there to intimidate you, and it doesn't matter. The steps are still the same. Doesn't matter at all. First thing, take these percentages, divide them all by 100. I say that it's the same thing as Miss Cole's scoop method whenever she teaches you to scoop the decimal 2 places. Because we do not need these percent abundances of these elements sitting there as percentages. We need them as decimals. So like the first one here, neodymium 142 is 0.272, 143 is 0.122, 0.238, 0.083, 0.172, 0.057, 0.056. Those are the percent abundances you guys should have got. I'm going to zoom in a little bit just in case those are hard for you to see. Now here comes the fun part. This is the only thing that changes, is how long this thing is. Because what we have to do use parentheses. You take the mass number, so 142, and multiply it by the decimal of that percent abundance. Don't multiply by the actual percentage. If you put that percentage in there, you're 100% wrong. You're no longer going to use these. Take those out. You're not using them. You're going to use these. That's why you did that. So 142 times 0.272 in parentheses, add to that the quantity 143 times 0.122 plus 144 times 0.238. You say, Mr. Hall, you're moving really quick. I know I'm moving a little fast. Listen, I'm moving a little fast because it's the same thing. All I'm doing is taking this mass number, multiplying by it to percent abundance decimal, and then adding them all together. So 144 times 0.238 plus 145 times 0.083 plus 146 times 0.172 plus 148 times 0.057 plus 150 times 0.056 in parentheses. Double check. 1, 2, 3, 4, 5, 6, 7. 7 of them, I'm good there. Let's type this all in a calculator. I'm going to show you how I like to do it. Whenever I'm typing the whole thing in the calculator, this is what it looks like for me. Parentheses 142 times 0.272 in parentheses plus parentheses 143 times 0.122 in parentheses plus parentheses 144 times 0.238 in parentheses plus parentheses 145 times 0.083 in parentheses plus 146 times 0.172. I think you guys are catching the drift here. Hopefully you are. In parentheses, so I get the average atomic mass of neodymium to be 144.325. Now, Mr. Hall made a mistake. He should have put the units with every one of these mass numbers. I apologize I didn't. Kind of in a rush. Not an excuse. I shouldn't have done it. I get it. You're yelling at me right now. It's a good job. You got it. I should have put the units. The units matter. So what units should be here? You have two different ones you can use. AMU for atomic mass units, or my personal favorite, grams per mole. That's the one that I like. So there is the answer to number 1. And you can compare that to numbers and values off of the periodic table. Remember, I will give you the periodic table, so don't be that worried about it. Now, we want to stress something. If you look at neodymium right here, number 60, it gives you 144.24. Look at what we got, 144.325 grams per mole. That's close. Don't be that worried about it if it's just a little off like that. Now, if that 4 was a 7 or a 6 or even a 5, that's a big problem. Okay? So number 1 was kind of long. Like I said, follow the process. Let's get started here on number 2. So we have boron. Now the cool thing with this is where there's only 2 isotopes, you can kind of tell how the average atomic mass is going to lean in what direction and what number it's going to be closest to. The greatest percent abundance is 80.1%, and that's for boron 11. So the average atomic mass is going to lean closer towards boron 11. What I'm saying is you'll see in a second. So first thing we got to do is divide these by 100, these percent abundances, so we can get that decimal so we don't make that mistake. So 0.199 and 0.801. Now we set up our problem. So let's do, I have boron 10, so 10 grams per mole times 0.199 plus 11 grams per mole times 0.801. I type this in a calculator. To get 10.801 grams per mole. See, this is what I'm saying. That 10.8, it's much closer to 11 than it is to 10. That's another way of checking ourselves. If we look on boron on our periodic table, we get 10.81, which is a good thing. So I feel pretty confident in that answer. Now, I want to stress something to you guys. I know I've stressed to you about units and how important they are, and units are important. This is what I'm saying. If your units are not here at your final answer, and I'll actually ask you to square or put a box or something around your answer so it's clear to me. If your units are not here, then you're wrong. 100% wrong. You have to have units in your final answer. You see here up top where I hadn't put the units, but I put them here? If you do that on the quiz, this is totally fine. I will give you full credit for that. Why? You have the units here. That's what matters. Now, here, if these units are not on there, you're okay. That's in the actual problem. I'm not going to look at the math and take the points off because you didn't put them actually in with your calculations you wrote down. You got them here. That's where it matters. Alright? So I thought now would be a good time to stress that to you guys because you guys are not used to me yet on my quizzes and how I work. So here and here is where those units have to be. All right? Now, moving on. Try and get me some room. There we go, that works. All right, number 3. Hopefully you're getting pretty good at these. If you're getting pretty good, if you want to stop, pause the video, and give it a shot yourself, go right ahead. So let's look. I'm going to move a little faster. Magnesium. Let's divide all these by 100 so that I can have that decimal of that percent that I need. So 0.7899, 0.10, and 0.1101. So you also can look at this one and say that it's going to lean more heavily towards magnesium 24. So let's do 24 times 0.7899. You can put those units in there if you like. I'm not doing it to try and save time because I got a lot of videos I'm making today. 26 times 0.1101. We do all that. Let's punch it in our calculator. So parentheses 24 times 0.7899 in parentheses plus 25 times 0.10 in parentheses plus 26 times 0.1101 in the parentheses. Hit enter. So I get 24.3202, and this is where the units have to go. So if you just leave it as 24.3202, now that is incorrect. You have to put that grams per mole or those atomic mass units, AMU. Okay? Let's look here. Sorry, I have to keep moving my stuff. Let's keep rolling right along. And let's look here at number 4 for chlorine. So you guys probably have picked up, it should lean a little more towards the 35, but it's not going to be exactly on 35, especially because look at chlorine. It doesn't go 35, 36, it goes 35, 37. That'll play a factor in as well. So let's divide these percent abundances. Ooh, what is going on here? My pen. Divide these by 100. To get the decimal of that percent abundance, 0.7578. So sorry, 0.2422. So now we can set this up. 35 times 0.7578 in parentheses, plus parentheses, 37 times 0.2422 in parentheses. Yet again, I'm not putting those units in there, just trying to save me some time so I can get these videos made for you guys. Couldn't read my own writing there for a second. 22. So we get 35.4844. Remember, grams per mole. Boom. There's that for chlorine. So, I'm hoping you guys are rocking and rolling with this. Let's do titanium, the last and final one on this average atomic mass practice. I hope you've picked up, it's the same steps. Nothing has changed. It's the same step every time. And that's what I'm wanting. The same steps every time. Only thing that changes is how many of these isotopes I have. And remember, I have to give that to you. Now I want to stress something to you. I know a lot of you guys are probably wanting to live on the edge and you don't want to write this out. This part up here showing your calculation stuff. If you don't want to do that, that's fine. If you just want to throw it into a calculator. If your answer is wrong, then it's just wrong. I have nothing to give you partial credit for it. If you put it all out and showed that you were going to work, you had it all work properly, but you punched in the calculator wrong, I can give you some partial credit for that. So I encourage you to write this stuff out like I am right now. So divide these all by 100. decimal of our percent abundance. So 0.08 to 5.0744, 0.7372, 0.541, 0.0, I'm sorry, that should be a 0 there. That should be a 0.054. I just need to white it out. I need to do it right. I apologize. Caught my mistake. 0.0541, 0.0518. Then we set these up. Isotope 46 times 0.0825 plus 47 times 0.0744 plus 48 times 0.7372 plus 49 times 0.0541 plus 50 times 0.0518. Let's throw this all in a calculator. So like I said, if you don't want to write this all out, that's fine. It's up to you, but I'm telling you, I recommend it. Take the extra time. It's worth it. The simplest mistake can happen. You'll be happy if you make a simple mistake and you get partial credit because you accidentally hit a wrong number in the calculator instead of you getting no credit because you put the wrong answer. So 47.9183 grams per mole. Boom. Now, yet again, you need to make sure and put this stuff out there. You really do. Because let's say, for example, I did this really quick. And taking these quizzes are not a grade. It's not a race, guys. It is a grade, sorry. It's not a race. So let's say right here, when I typed that in, that I made the mistake I had before. So let's go to the 49th isotope. Now let's take that 0 out. So I'm going to take that 0 out. There we go. Look at the difference in the numbers. If you just type this in a calculator and you hit 71.7764, if you just type it in, you put that down on your paper, that's 0 points. I can't give you anything. But if you put that down and you have all this wrote out, I'm going to be looking and going, what did they do? They have it all wrote out here, and I'm going to give you the credit. And I'll probably even ask you, I'll write on there, what did you do? Question mark, because I'm curious, how did you mess up? You have it all right here. Alright? So if you guys have any questions on this average atomic mass, please come see me. Do not wait. You need to come see me now. Don't be waiting around.